Today, we'll be talking about integration by substitution using the algebraic method. Let us start with some examples. The integral of x over the square root of x minus 3 of dx. Preferably, you want to substitute the more complicated expression such as this, the square root of x minus 3. So, let u here be square root of x minus 3 or x minus 3 raised to the power of 1/2 because it is the same as this. And so, let us square both sides in order to get rid of it. So, it would be u squared equal to x minus 3. And so, let us get the value of x. Move 3 to the other side. So, negative 3 would be positive 3. And therefore, x here would be equal to u squared plus 3. And now, let us take its derivative. So, the derivative of u squared plus 3. The derivative of u squared is 2u. And the derivative of 3, which is a constant, is always 0. And so, just don't put it and multiply this by du. Now that we all have our input here, let us start substituting it. And so, it would become the integral of the value of x here would be equal to this, which is u squared plus 3 over the square root of x minus 3, which is the value of u. So just put u here. And the x right here would be equal to this, which is 2u multiplied by du. And so, let us start simplifying this. This u will cancel each other out. And so, you are left with the integral of u squared plus 3 multiplied by 2 du. And now, you can put u outside the integral. So, it would become 2 the integral of u squared plus 3 all multiplied by du. And now, this is now a simplified integral and we can now solve this. And so, we can split this apart. So, it would become 2 the integral of u squared of du plus 2 the integral of 3 du. And now, let us start integrating this one by one. The integral of u squared, based on the power rule, it would become u cubed over 3. The integral of 3 du, well, you can simply put 3 outside the integral, so it will become 6 the integral of du. And so the integral of du is simply u. So it would become 6 multiplied by u. And don't forget to add the constant of integration. Now, let us not forget to substitute u back into its original form. And so, 2/3. And u here is equal to this one. So it would become x minus 3 raised to the power of 1/2 all raised to the power of 3. Because do not forget that this is raised to the power of 3. Plus 6, and the u here is equal to x minus 3 raised to the power of 1/2 plus c. Let us start simplifying this. 2/3 multiplied by x minus 3, 1/2 raised to the power of 3. It is simply 3 multiplied by 1, which is 3 halves, plus 6 multiplied by x minus 3 raised to the power of 1 half plus c. We can now simplify this even further by putting it in a radical form. So the final answer here would be 2/3 the cube root of x minus 3 plus 6 multiplied by the square root of x minus 3 plus the constant of integration. The integral of x over 1 minus x squared plus the square root of 1 minus x squared of dx. And now, let us substitute the more complicated expression, which is the square root of 1 minus x squared. So, let u here be square root of 1 minus x squared. And let us square both sides. So, it would become u squared equal to 1 minus x squared. Isolate x, so it would become x squared would be equal to 1 minus u squared. Taking the square root, it would become x would be equal to the square root of 1 minus u squared, or it would become 1 minus u squared raised to the power of 1 half. And now let us take its derivative. This applies to the chain rule, wherein you have to focus on the outer part first. So it would become 1 half because you will bring this down, multiplied by 1 minus u squared, and subtract this by 1. So 1 half minus 1 would be equal to negative 1 half. And let us multiply this by the derivative of the inner function. The derivative of 1 is 0, and the derivative of negative u squared is negative 2u. And multiply this by du. And so let us simplify this. Let's just bring this up. Dx right here now would be equal to 1 multiplied by negative 2u du over 2 multiplied by the square root of 1 minus u squared. Keep in mind, we bring down the square root of 1 minus u squared because it is a negative exponent. And so, simplifying this, these two will cancel each other out. So, the final dx right here would be negative u du over the square root of 1 minus u squared. Now that we have all our inputs, let us substitute it. So, the integral of the value of x here would be equal to the square root of 1 minus u squared over 1 minus the value of x squared here would be equal to this, which is 1 minus u squared, and the value of the square root of 1 minus x squared would be equal to this, which is u. And let us multiply this by the value of dx, which is this, which is negative u du over square root of 1 minus u squared. Now let us simplify this expression. As you can observe, the square root of 1 minus u squared and this one would cancel each other out. And so, it would become the integral of negative u du over 1 minus 1 plus u squared plus u, because you distribute negative to this. So it will become positive u squared. And so 1 minus 1 here would be equal to 0. And so, you can observe here that u squared plus u can be factorable. And so, it would become the integral of negative u du over the factor of u squared plus u would be u multiplied by u plus 1. And so, the u here would cancel each other out. And so, let me just make some space here. And so, the simplified integral expression right here would be the negative integral of du over u plus 1. I just brought outside the negative value. And now, you can see here, this is based on the logarithm of integral, wherein du over this would be equal to ln of absolute value of u plus 1 plus c. But we are not still done yet here because we have to substitute u back into its original form. So, negative ln, the absolute value of u here is the square root of 1 minus x squared plus 1 plus the constant of integration. This shall now serve as your final answer. The integral of dx over the square root of x plus 1. So, let us substitute u here. U here would be equal to square root of x, or x raised to the power of 1/2. And so, let us square both sides, so it would become u squared would be equal to x. And so, since x here would be equal to u squared, taking the derivative of this, the derivative of 2u of u squared, would be equal to 2u multiplied by du. And so, let us start substituting it. It would become the integral of the value of dx is 2u du over the value of square root of x would be equal to u plus 1. First, let us put 2 outside the integral. So it would become 2 the integral of u du over u plus 1. And so, we cannot factor u plus 1 here in order to cancel u there. And so, what we're going to do is to divide it. So, u plus 1 divided by u, which is the upper. And so, u divided by u would be equal to 1. And so, 1 multiplied by u would be u. This should be negative. 1 multiplied by 1 would be 1. And so, u minus u would be 0. And negative of 1 would be negative 1. So, this would become simply the remainder of negative 1. And so, this would become 2 the integral of 1 minus 1 over u plus 1 multiplied by du. And so, this integral now is now simplified, and so we can split this integral apart. So it would become 2 multiplied by the integral of 1 du minus 2 the integral of 1 over u plus 1 of du. Let me just make some space. So, let us first focus on this. The integral of 1 du is simply u. So, it would become 2 multiplied by u minus the integral of 1 over u plus 1 of du. This is also can be referred to as 2, the integral of du over u plus 1, which fits the logarithm of integral, wherein it would be 2 ln the absolute value of u plus 1 plus the constant of integration. And let us substitute u back into its original form. So it would become 2 multiplied by the value of u, which is square root of x, minus 2 ln the absolute value of u, which is square root of x, plus 1 plus c. Now this should serve as your final answer. The integral of 4x minus 1 over 2x plus 1 raised to the power of 3 halves of dx. And now, whenever you're dealing with a radical here, you preferably want to put it in the form of square root or raised to the power of 1 half, not raised to the power of 3 halves. And so let us rewrite this problem. So it would become the integral of 4x minus 1 over 2x plus 1 raised to the power of 1 half. And let's raise this to the power of 3. This expression is the same as this. We just simplified it in the form of square root, because 1 half raised to the power of 3 is simply 3 halves. We just simplify this. And now let us start substituting it. U here would be equal to 2x plus 1 raised to the power of 1 half. Let us square both sides, so it would become u squared would be equal to 2x plus 1. Isolate x, it would be u squared minus 1 over 2. And taking its derivative, this is quotient rule. So copy the lower portion first, which is 2, and multiply this by the derivative of the upper portion, which is u squared minus 1. The derivative of u squared is 2u, and the derivative of 1 is 0, so no need to put it. And now let us subtract this by copying the upper portion first, which is u squared minus 1, and multiplying this by the derivative of the lower portion, which is 2. The derivative of 2 is 0, and so this would cancel because it is equal to 0, so no need to put it, and over the square of the lower portion, which is 2 squared, which is 4. Now simplifying this, dx right here would be equal to 4u over 4, and don't forget the du here. And so 4 here would cancel each other out. So the final dx value here would be equal to u multiplied by du. And now let us start substituting it. So it would become the integral of 4. The value of x here would be equal to u squared plus 1 over 2. Let me just erase this. Minus 1 over the value of this is equal to u. And don't forget, it is raised to the power of 3. So it would become u cube. And let us multiply this by the value of dx here, which is u du. Simplifying this, u here will cancel, so it would become only u squared now. And 4 divided by 2 would be simply 2. So the integral would look like this: 2 multiplied by u squared plus 1 minus 1 over this should be u squared minus 1. Should be u squared minus 1. Because it is based on this x value. And so, over u squared multiplied by du. Simplifying this, it would become the integral of 2u squared minus 2 minus 1 over u squared du. So this would become the integral of 2u squared minus 3 over u squared of du. Now that this integral is simplified, we can now solve this. So let us split this integral apart first. The integral of 2u squared over u squared of du minus the integral of 3 over u squared. Wait, let me just rewrite this. 3 over u squared of du. So, put the constant first outside the integral. It would become 2 the integral of u squared over u squared of du minus 3 the integral of du over u squared. And so u squared here would cancel each other out, which would be equal to 1. And so it would become the integral of du is simply u minus the integral of du over u squared. This is not based on a logarithm because you can do it like this. U squared, when you put it at the top, it would become u raised to the power of negative 2. So this is basically the integral of u raised to the power of negative 2 of du. And so based on the power rule, it would become u negative 2 plus 1 would be equal to negative 1 over negative 1 plus the constant of integration. Simplifying this, it would become 2u plus 3 over u, because since this is a negative exponent, put it below, plus c. But we are still not done here yet. We have to substitute it back into its original form. And so the final answer here would be 2 multiplied by the value of u, which is square root of 2x plus 1 plus 3 over square root of 2x plus 1 plus the constant of integration. You can simplify this further, but I will leave this as it is.